Good morning, class 10 students. I welcome you all on this online platform provided by JAGRITI classes. We were discussing chapter 5, that is the chapter of chemistry, periodic classification of elements. So now we'll be starting or continuing this chapter. In the previous video lecture, we discussed that how these elements which came into existence were classified. Because as the elements were continuously being discovered, then there was a need felt for classification. So, today we have 118 elements and more. But previously when the elements were discovered, that is when we had 40 to 50 elements, then some scientists or researchers tried to classify these elements into certain groups. So one of the initial research or the classification was based that two groups were made. One was metals and the other was non-metals. So the scientists said or proposed that all the elements which are discovered can be divided into two groups. One would be of metals and the next of non-metals. But now we have next was when approximately 56 elements were discovered. Then a new scientist, that is Robenier, he tried to make a classification of these elements and he tried to arrange these elements in a group of three, which we refer as Robinier's triad. So Robenier was the scientist, but we saw its classification. It was quite good in the way that he actually put a first foot forward to emphasize on classifying according to certain properties, that is according to the mass of elements. Then we saw the demerits faced by Robenier, and so a new classification system evolved, which was of Newland. So next we had Newland system of classification, which was in a group of 8 elements which were grouped together, and it was about Newland's law of octave, or it was known as Newland's law of octave. And we discussed what do you mean by Newland's law of octave. It is similar to the 8 musical notes which we have with us, okay? So like we have the notes to be sa, re, ga, ma, pa, dha, ni, and then the next is just same as first, that is sa. So in turn he said that after every 7 elements, the 8th element will have same properties to the first one. And he described the table according to atomic masses, that he kept the elements in increasing order of their atomic mass. That is, if you move from the first element towards the right hand direction, then you will see that the elements coming after this first element would have a greater mass. Let's suppose if the first element present on the extreme left has a mass of 1 unit, then the elements after that would have some or the other mass, but this would be definitely in the increasing order, okay? He didn't say that mass would be, the difference in the masses would be 1 unit or 2 unit. He just arranged them in increasing order of atomic mass. But we also studied the demerits about Newland's law of octave, okay? But now we have a next classification of our elements, which is Mendeleev's periodic table or Mendeleev's periodic law. So now the topic of our discussion is Mendeleev's periodic table. Now you have to understand what this periodic table signifies, or what was the postulates proposed, or what kind of arrangement did Mendeleev propose. So till the time of Mendeleev, approximately 63 elements were discovered, okay? Till Robinier's and Newland's, we had only 56 elements discovered, and Newland told that we saw in the demerit or drawback that Newland didn't left any empty spaces, okay? He didn't left spaces so that we can put our noble gases which were not discovered. These noble gases were instead not discovered till the time of Mendeleev also. But what Mendeleev did is, Mendeleev left some gaps or empty spaces, and when after Mendeleev noble gases were discovered, they can easily be put in his periodic table without disturbing the arrangement. So this was the plus point or merit of Mendeleev. So now we are starting Mendeleev's periodic table. Mendeleev's periodic table contains 63 elements in total. That is, till Mendeleev's time, 63 elements were discovered, and he arranged all these 63 elements into a tabular data form. So, the full name or the complete name of Mendeleev was Dmitry Ivanovich Mendeleev. So Dmitry Ivanovich Mendeleev, in the year 1869, he proposed his periodic table, or he classified all the 63 elements present. And this classification is based on Mendeleev's periodic law. So what do you mean by Mendeleev's periodic law? Mendeleev suggested that all the elements which we have now, or which were discovered until Mendeleev, he suggested a statement that the properties of elements are periodic function of their atomic masses. Okay, so this was what Mendeleev suggested, that all the properties of elements all the properties of elements are a periodic function of their atomic mass. That is, Mendeleev also considered the property which atomic mass. So I'll write probably the statement. He told that all the elements, all the properties of elements are a periodic function of their atomic mass. Now firstly, we'll understand what we have written, that is this law. What does this law actually signifies? This law means that if you are considering elements, particular elements, let's suppose we have 3 elements with us, A, B and C. If I told you that the mass of A is 10 units, the mass of B is 25 units, and with C we have a mass of 50 units. Okay? If let's suppose I am explaining the law with an example, if you have 3 elements with you, each with their respective masses, then Mendeleev said that all the other properties will be a periodic function of their atomic mass. That is, if you see a trend of increase or decrease in your atomic mass, then other physical and chemical properties would be related to their mass. Let's suppose now I am considering any property. That is, let's take boiling point. So the element which has a lower mass will in turn have a lower boiling point. So the boiling point of this, if the boiling point is 50 degrees centigrade, then the next element which has more mass than the previous one would have an effect on the property also. The same trend would be observed in property. That is, if the mass is increasing, its boiling point can increase. So let's suppose if the mass increased from 10 to 25, then the boiling point increased from 50 degrees centigrade to 75 degrees centigrade. This all I am discussing is a hypothetical or an imaginary case, okay, because I just want to explain you the statement. What does Mendeleev's periodic law states? It means that all the properties, whatever property, whatever physical or chemical property you may consider, they would be a periodic function of atomic mass. That is, if you consider the mass of any elements and the property will be related to the mass. Let's suppose I took here that boiling point would increase on increase in atomic mass. I take any other property. Let's suppose I am taking a property X. So I say that the value of property X is decreasing on increasing of mass. So you can get the property might increase or it might decrease, but this increase and decrease, this trend is related to atomic mass of elements. In turn, Mendeleev arranged all the elements in increasing order of the atomic mass. And what do you mean by this term, periodic function? This was much similar also proposed by Newland, that the properties are a periodic function. Periodic function means the properties show periodicity. We can write that periodic function means the properties show periodicity in them. And periodicity refers, this term means that repetition observed in properties after a certain interval, after a certain interval of time. Okay? So periodicity means if you observe that any next element has a similar property to the first one, and this periodicity was also explained in Newland's law of octave. Okay? But he said that properties repeat after every 7 element. That is, the first element and the 8th element will have same properties. But here Mendeleev only gave the term periodicity. He did not explain that after how many elements periodicity would be observed. That was in the case of Newland only. So, but this term was quite important, and so our arrangement of elements in a tabular form is called periodic table. Because in modern periodic table, when we will discuss, let's suppose this is our modern periodic table, okay, just giving you a rough idea. So what do we have in this? That if I consider all the elements coming in one group, then all these elements will have same properties. Many properties of these elements would be same. So this is what you mean by periodicity, and so these tabular forms were called periodic table or periodic forms. So now next, the table which was proposed by Mendeleev is well given in your books, and we'll draw this table, okay? So now I'm drawing the table. No need to memorize the table. In fact, what Mendeleev did is, he drew a table. He arranged all the elements in 8 vertical groups. So it was first, second, third, fourth, fifth, sixth, fifth, sixth, seventh, and then you have 8. So Mendeleev arranged all these elements in the 8 vertical groups, and then he divided the first 7 groups into subgroups also. So you have 2 subgroups for first, and in the similar way he divided all the first 7 vertical groups into subgroups, and he named the subgroups to be A and B. He said that all the elements which come in this group, in a particular group or in a particular subgroup, they will show similar properties. So this was proposed by Mendeleev. You can write it in the form of statements also. That is, Mendeleev arranged all the elements in vertical columns which were referred to as groups. You can say VCG, that is all these are the first alphabets. VCG means vertical columns. What you have, these are the vertical columns. So Mendeleev said that you have 8 groups in your periodic table. Next Mendeleev did was that 8th group was not divided in the subgroups. So how many subgroups do you have? Mendeleev told you have 8 groups in your Mendeleev periodic table, and you have how many subgroups? You have 14 subgroups. Then Mendeleev divided all the elements in 7 periods, okay? So he made 7 periods. That is, he made 7 rows, which he named as periods. So the 7 rows will be 1, 2, 3, 4, 5, 6 and 7. I am again repeating, there is no need to learn the periodic table. You just have to learn the features of this periodic table which were proposed. And the features I am writing simultaneously, that is, you will not get any question ki draw Mendeleev periodic table. Okay, because it is very time consuming and it is of no use. We have rejected this periodic table. We just should know the features, that is, it divided, Mendeleev divided all the elements into vertical columns which were known as groups. So we had 8 groups. And because the first 7 groups were further divided into subgroups, each had 2 subgroups, so we had a total of 14 subgroups with us. Then he called these horizontal rows. He called the horizontal rows. Horizontal means from left to right. So these he called period 1st, 2nd, 3rd, 4th, 5th, 6th and 7th. So these are the different periods which we have with us. So I can denote here that these are the periods which you have, and the above ones which I have written in new Roman numbers is your groups. So these are your groups, and the next one is your period. So in turn you have to remember that how Mendeleev classified the elements in groups and periods. Now the next is what? You will see that now many other features of Mendeleev, that is, if any element was present in one group or in a period, then it showed similar properties. Let's suppose Mendeleev kept hydrogen here, then noble gases were still not discovered till Mendeleev observed or made his periodic table. So we can write noble gases were not discovered. But what Mendeleev did, he left some empty spaces for these noble gases. So again, this is a merit of Mendeleev that he left empty spaces for many elements and noble gases. Because we know hydrogen comes here, then helium was not discovered, then we have lithium, then we have sodium, okay, and this is much similar what we have in our modern periodic table. So these were the elements which were coming in the first group and in the first subgroup. And likewise all the elements were arranged. You can quite simple, it is very simple, you can see in your books how these elements were arranged. Let's see the other elements which are coming from the period 4 were copper, silver, gold. So you have in this, after potassium you have copper, then you have silver, then you have gold. These are the elements, copper, silver, gold belong to the subgroup B, and these all elements belong to your subgroup 1, subgroup A. Then the next you can see in your books, you are given that starting in the group 2, from period 2 you have beryllium, magnesium, calcium, strontium, barium and radon. That is in group 2, period 2, you have beryllium, magnesium, calcium, strontium, barium and radon. Okay, so likewise we can form our table. Now the important elements I'll write which we have to study, that is which we can study their properties and all, or the merits and demerits. So the first, I have already told you the features, that is he made 8 vertical groups and then he divided into 14 subgroups. Then you have 7 periods, that is 7 horizontal rows. These are your periods and these are the groups. Then he observed periodicity in properties, that is he said that this hydrogen possesses similar properties with lithium. So what were the similar properties? You can write that all elements coming in same group had similar properties. And what was similarity? That is, they had same valency. All the elements which are present in one group or the common group had same valency. That is, hydrogen, lithium, sodium, potassium, and every element coming in group 1 shows a valency of +1. So we can write this, that valency of elements coming in group 1 is 1, and the valency of all elements coming in group 2 is 2. All the elements which will come in group 3 will have a valency of 3. Then you have a valency of 4. Here carbon comes, here you have silicon. Then next, once valency is increasing 1, 2, 3, 4, then it would decrease. That is 3, 2, 1. And Mendeleev didn't give any idea that what would be the valency of this 8th group. All the elements coming in 8th group will have how much valency? Either it would be 0, or it would be equal to 4, or it would have any other number. So the valency, Mendeleev had no idea about the valency of the elements which will come in this. And in fact, Mendeleev arranged elements in the 8th group in group of 3. Okay? So you can see in the group, in the book itself, that Mendeleev kept in the 4th period 3 elements which were iron, cobalt, and nickel. So likewise in 8th group he placed a triad, okay, a group of 3 elements. So these were the 3 elements which he put in his Mendeleevian periodic table. Now what were the demerits? We have done the structural features, that how Mendeleev arranged, how many columns he made, how many rows he made. And then we had did that, what do you mean by periodicity? And some of his merits, you can say that he left empty spaces for many elements which were yet to be discovered. Then other merit was all the elements which came in the same group showed similar properties, that is, they had same physical properties, same valency. Then Mendeleev also proposed a term, that is, he left certain empty spaces. Okay? You can see in your books that empty spaces are given in your period 4. That is, after aluminium you have empty spaces. So why these empty spaces were left? Mendeleev proposed some of the elements which he said were missing and they would be discovered later. So he proposed certain terms, that is, eka-aluminium. Eka-aluminium was the term which was proposed for element which would occur after, that is, that would be discovered afterwards. Then he also proposed a term, eka-silicon. That is, the silicon के बाद जो element discovered होगा, the element which would be discovered after silicon. So these terms, and he also said that these elements were yet not discovered, but empty spaces, or you can say vacant spaces, were left for them. Empty spaces were left for these elements. But what Mendeleev proposed smartly, that these elements were not yet discovered, but in turn Mendeleev proposed their physical and chemical properties. Physical and chemical properties of these elements were discovered. And later on, when the elements were found, that is eka-aluminium, eka-silicon, okay, then we saw that the chemical and physical properties proposed by Mendeleev were the same that we have now. So this was the account of Mendeleev periodic table. Now we have many other structural features and merits and demerits to be discussed for this Mendeleev periodic table, which we'll be doing in our next class. But today what we discussed was very important, that is the term periodicity, and at least you should understand the structural features which were included in the Mendeleevian table, that is how Mendeleev divided these elements in different columns and different laws. Then remember the next important feature, that is noble gases were not discovered until Mendeleev made this classification. But in turn also, for the occupants of noble gases, he left some vacant spaces where you can put your noble gases. And this was a great advantage given to Mendeleev. That is, when later on noble gases were discovered, then no arrangement of Mendeleev's periodic table were need to be altered. Okay, the arrangement of that periodic table was kept same, and this was a great advantage which was with Mendeleev. So this was all the account of Mendeleev periodic table, and I am telling you we'll be discussing more about Mendeleev periodic table in our next class lecture, and then we'll discuss the last topic, that is the modern periodic table which was proposed by Moseley. So thank you for joining the class today, and if you have any sort of queries or doubts, you can ask anytime. Thank you.